a lot of very cool things came up in this process. And right, a brief history of regular expressions is right here. One of the most important things that we might use it in our era of large language models would be effective pre-processing, so you can reduce the load on your model, right? And XKCD has wonderful comics on regular expressions. They are very popular. Once you get a hang of them, it does add a lot of joy and happiness, especially to my experience in this space. Next, I'd like to look at some terminology that might be useful while we discuss regular expressions. First up would be a pattern. So this is a construction that we are going to be using to match strings across our text. So it could look something, it could be a bunch of symbols next to a bunch of letters, and that's what you're feeding to your search engine, right? Next, we have a string, which is just a set of characters that are arranged together. Our characters here could be letters, digits, or symbols. Right, and so these are some characters include the alphanumeric set. So if you're only looking at letters, then you'd use an A to Z set. If you're looking at numbers, 0 to 9. And along with these letters and basic characters, there are a lot of meta characters, which are special symbols that will translate to certain tasks when you use a regular expression. Now, if you want to use these symbols literally, you would have to add a slash to escape, so that your regular expression reads them as a literal character rather than a meta character. Some examples of meta characters are dots and stars. Very common to want to define a period and accidentally ending up with using the dot wildcard, right? Now, besides some of the important symbols here include meta characters include the wildcard search. So if you use a dot, that signifies one or more instances of something that you're searching for, and the clean star is indicates 0 or more. So rather, you can, besides defining exactly how many number of times you want to see something repeated, wildcard searches basically help you construct your regular expression if you're not interested in specific numbers, right? Brackets are fairly important in regular expression as well. The three main types that you'll see across across today's presentation and most regular expressions would be, say, the curly bracket, which is a quantifier. It defines how many instances of a pattern you'd like to see. We've got the square brackets, which basically create a list of characters. Anything inside square brackets is going to be treated as a list. So look for any of the things inside a square bracket. Finally, we have the round brackets, which are used to create a group. So if you'd like to look for the word, if you'd like to look for multiple instances of the word cat, but you know that that CAT might be surrounded by other letters in a word, we might want to use round brackets in order to create a group to specify what we want returned. Finally, we have anchors, which so we've got the start of the line as well as the end of the line. So if you're specifically looking for your regex search to return things that are located at the start or end of a line, these would be great. This would be a great use case for anchors. Next, why would we use regular expressions? First, like advanced searches, really, it all comes down to advanced searches. No matter what platform you use or what it is that you'd like to target, it's fairly necessary for us to basically make sure that our search parameters are specified correctly. Regular expressions have been the history and backbone of natural language processing, and a lot of the language models that we see today at some backend or under the hood are using some form of pattern matching, and this makes a knowledge of regular expressions really useful in making sure that you are providing a cleaner data to a large language model, if that's your use case. If you're just looking at running things on your own system, they run very efficiently, very fast, and the overhead is quite minimal. Another use case is a lot of models may not be trained to look for specific patterns that you need. And constructing a regular expression is a great first step. So a lot of this work would be targeted towards data pre-processing, just a little data exploration. And of course, if you are using, say, Google Docs, you're working on your own word processor, makes more sense to have an advanced search option so you can improve and optimize your work with text, right? Now, one of the main issues with using regular expressions is we want to make sure that we know what kind of behavior our regular expression is going to give us when we write one. So validation becomes key, and like two very simple tools that you can use are a platform like regex 101, where you can provide just a little bit of text as well as your pattern. The other thing is just brainstorming with large language models, ChatGPT or any tool that you'd like. You can give it your prompts, your word prompts, and they would be really good at returning a regular expression to fit your use case. They're also good for just asking questions and trying to determine what kind of regular expression you might need. And yeah, great. They work great with code, and regular expressions is no exception to this. Okay, so just a quick look at regex 101. The website, this is basically what it looks like. The moment you start typing a bunch of symbols, you'll notice that if you make a mistake, it'll tell you, hey, you made an error. Something's up with your code. And if you add something more logical, like .star, you see an explanation where it tells you in plain English what it thinks your regular expression is going to return, right? So you've got a nice, it's also got a really nice debugger. So if you'd like to like test your regular expression before deploying, great tool for all your use cases, for getting an overview of how to use this, yeah, and debugging. Oh, sorry, right. Next is regular expressions can be used across programming languages as well as platforms. Now, I just have 3 brief examples here, but they are by no means, the use of regex is by no means limited to this. First, if you'd like to run a command line tool, if you'd like to run a regular expression search with command line tool, grep is a great tool. So I have a little code here that extracts phone numbers. So it's just going to look for a list of zeros of more than one instance of any number or a hyphen, right? So if you run this, it will basically print the result, which we can do right here. All right. While this runs, the other option is regular expressions with Python. Python has a RE library, which has a whole bunch of code instances, classes, and all kinds of useful tools that you can use to basically deploy your regular expression in a Python environment. So I've given a little example using re.match. And a lot of my examples down here for some of the symbols and characters I explained above are going to be in the Python environment, right? So here I've just written a little function that's going to that's going to require a string as well as a pattern. And if it senses a match, it's going to print a little sentence which tells me that it's a match. And if it doesn't sense a match, it's going to print a different and alternative sentence. Right, so let's see how this works. I'm just going to run the next code chunk as well. So here, I have an example for the wildcards. I'm looking for, in the first example, I'm looking for some word which starts with a capital T and contains a bunch of other strings. In the second instance, I'm trying to match a word which has one or more instances of a capital T. And in the examples with letters, digits, and alphanumeric characters, I'm trying to match a W character, which is any number or word, anything that's not a symbol. And I'm trying to see if it will return a match for the string I have, right? Next, I can use the /s symbol to look for spaces. So if I, for whatever reason, I just want to get a sense of how many times the space how many times the space symbol exists in my text, this would be an example of how I can use it. If I'm just looking to count new lines, I can use the /n. Right, and there are some other examples for the curly braces, the round braces, and the anchor. Right. Now, if I'll give you a few minutes just to briefly look at the input and output of the code here, and this might be a good opportunity to maybe create a little code block over here and play around with the examples. See what, and the other thing that you can do is simply copy the code, the regex pattern that I have here, paste it into regex 101 and see what the explanations are like. So just take a few minutes to get a sense of the symbols, and we'll look at some other ways in which we can apply these. Right. So while you're in the process of looking at some of the code examples that I have here, let me just consider a couple of examples, just a sense of reading the regular expression into plain English. In the last input the last input and pattern that I've provided, re.match asks for, first up, it's asking for 0 or more characters. So it doesn't care what appears before. It's going to then look for a C, followed by a group, which is the AT, and then something that follows all of this. Right. So now in this specific context, I'm looking for any word which contains CAT, but what I want my regex to return is the group AT. So that's kind of what I was trying to do. There's a lot of ways to achieve what I did. I tried to go for the simplest regular expression that I could write, but there's never any restrictions on how complex we can go with this. The other option, as far as platforms go, and I'm touching on this very briefly for the R users, there is a grep library in R as well. It's something that I used to use quite extensively. And the way to use the grep library is to provide it with a pattern, text, and I believe you can also provide it with a value, and it will print out your matches for you, right? So I'll need to run R magic to get R to run on my collab notebook. But I basically looked at three strings that I provided the engine, and I asked it to match anything that contained a number. So that's where the any combination of 0 to 9, one or more instances of a 0 to 9, and it returned the first two strings, but it did not return the last string, right? So whether you're using it on command line, on R or Python, or you're writing a code on, you're writing your document on Overleaf or Google Doc, there's regex options across platforms, and it really does add to what we're trying to achieve with our code. Now, at this point, I'd like to just briefly talk on a little group project that I thought we could work on together. Um, Now, in this group project, I looked at a popular open source data set. This data set contains a bunch of fraudulent emails. There's a lot of Nigerian princes out there who are trying to find descendants. There's people who want you to file your taxes right this second, or you lose all your savings. It's all kinds of craziness out there, and a very fundamental use case is trying to separate your spam from your non-spam emails. And in the context of looking at an email corpus, in this case, it's a relatively small corpus. I believe it's about 3 MBs, but consider if you had billions and billions of emails, before you or provide this to a large language model to let it crunch up everything. Maybe there's something that we can kind of look at on our own system, get like a little sense of what the data is that we're working with before we move on to big deployments, right? So the first thing that I'd like you to do is load the data set. I've just written a little code. I found this data set on GitHub as well. The original source that I found was Kaggle. So if you run the next two code chunks, it'll print out a couple of lines for you. Now, I just got the code to print the first 300 lines for me, but something that I'd like all of us to do before we move on is maybe print a different set of lines. Instead of 300, maybe try printing printing like the last 300 lines, or something between 300 and 800. And I'd like you to maybe look at some of the sections of this text and get a sense of what are the parts of an email that we as text processors might be interested in, and let's engage with our code a little bit. Now I'll take a little I'll give you maybe about 2 minutes to do a little bit of data exploration on your own system. And in 2 minutes, maybe or as and when your comments come in, please do use the Zoom chat, or just call out anything that stands out to you, anything that makes these emails seem suspicious to you, and maybe tell me what are the parts of this email that might be relevant to you in order to make sure that you don't receive more emails from a source like this. All right. I'd like you to take maybe 1 more minute to maybe formulate some comments on in case you've this is the first time you're encountering the fraudulent email corpus, or if you've seen it before, anything that stands out to you. Right. Could you say that again? Right. Yeah. So we have these fraudulent emails might come from a very specific email domain. So maktub.com, for example, is one that I see that I've seen a lot. So I might be interested in simply extracting the sender's emails, and for a particular project, instead of looking at the entire corpus, I might just be interested in looking at the sender's email, or for in order to get an initial overview of my text, I might just be interested in the subject line. No, maybe there's some pattern that in the subject line that could basically reduce my overhead for a project like this. So instead of crunching the entire email, by crunching a smaller section of each email, I can get my job done faster. Again, if you've had a chance to look at the text of the email itself, is there anything about the language that stands out to you, or any words or any numbers, anything that looks that might make you besides the meaning that the email is conveying, anything that might make you suspicious? Those in Zoom, I mean, you can always unmute and also shout out your answers. Right. Yeah. So there's like this big number, right? There's a $ number, like some 7 or 8 digit number, followed by like a bunch of decimals. So I mean, I don't know what line of work all of you work in, but if I receive an email with a 7 digit number in it, a dollar figure in it, especially, I would be a little suspicious. No, not I've not been a recipient of a major grant yet, so there's that. Anything else? What about like just in the text, like the people who are sending this mail to you, like something about the about a about the character, like something rather than reading the entire email, is there just like say 5 or 6 words that could tip you off about this email being weird? Yeah, exactly. So you've got manager, you've got like directors, kings, princes, you've got CEOs, you've got major minister in a government, right? When providing all this text to a natural to a language model, instead of using the whole corpus, maybe all we might need is maybe, let's say, 15 words out of whatever the 500 words that this email contains. So these could be some ways to kind of optimize our NLP input. And in case you weren't able to join us last week, I have some of my another notebook where we look at things like parsing and pause tagging. So you can extract all your filler words, all the things that you don't need, and simply come up with like a smaller chunk of words that you can provide to your NLP model. So right, sorry. Parsing would be just breaking down our text into linguistic units. So these just can be words that that they're nouns or verbs. So you can basically get some linguistic information inserted into your text. So that would be just very briefly what parsing would be. So but before we even work with a NLP pipeline, let's consider some of the contents of every email that might be of interest to us, right? So here, in the next couple of lines, I just wrote a very simple, readable for loop. Like there are very, very efficient ways to do this. I just wanted to do the simplest way that I could explain to all of you. So the first thing I wanted to look at was what are some of the important and relevant portions of the data set that we may need to extract. So I might be just interested in the from or the return email ID. Right, so that's something that's enclosed in a line of text. It's between angular brackets, so I might need to exclude everything in a line except the email ID, and I want a pattern that can give me an email ID. Right? Yeah, exactly, Randall. There are phrases like that. Yeah, there's no reason for anyone to send me an email with the word soliciting in it, for example, and that definitely would make me suspicious. Right. So the next thing could be just the subject line itself. Maybe you're interested in a subject line that says your urgent response is required, and I'm sure there are contexts in which urgent responses are important, but there are also that can be suspicious. Next could be just the message itself, right? A message which is written in all caps. Very, very rare for a human readable official email to be written in all caps. So yeah, that might be something that you want to look at. And before we proceed to using a large language model, this is something that we can just use with simple pattern match, right? Another thing could be very specific combinations of numbers and letters, right? It's in a human readable email, we might see a bunch of words and we might see a bunch of numbers separately. But if you have strings where zeros have been replaced by O's, for example, very suspicious. Next is if we want to determine a pattern to extract the relevant relevant elements. First, we might want to keep in mind the new line character. How many times is the space being used? In a typical email, the text in a paragraph is one block. But if after every 5 or 10 words, a random new line has been added, very suspicious. No reason for someone to just add random spaces in an email. Next could be we might want to consider what makes an email sound like spam. So like all of you pointed out, there's I am soliciting, unique opportunity, titles like king, prince, whatever. So one of something that we could do is create a pattern matching that looks for, instead of looking for everything, it looks for maybe certain key phrases. And that could be something that gives us a trend in the fraudulent email language. And of course, all this is before we pass on all of this information to an LLM. And one of the another major use case for it is if you want to convert your .txt file into something that humans can work with, like a data table. You might want every element of your email to be on a separate line. And a nice use case here would be if you know what the subject line looks like, you know what the for line looks like, you vaguely know what the email content itself looks like, simple regular expressions could go a long way to give you a data table, which is going to be a lot more easy for any system to process, as well as easy for someone to read, right? So with this, let me just take a look at the first code block in this section. So I've added there are some little notes here. You might need to click on the little triangle to read the points that I made there. But I've covered them in my talk, right? So the first thing is I want to try to extract just the sender address. Okay, I just want to create a little list. All I want is a sender address. If I have billions of lines of code of email content, like the easiest way would be to just create a pattern for it. So something that I noticed over here is I don't want any angular brackets. I want my line to start with, say, the word from, followed by a colon. And I want my pattern to ignore anything that's not enclosed in the angular bracket, right? So this would be just a simple way that I can extract email IDs from here, right? So if you uncomment the print lines, it would Might take a minute, but let's quickly take a look at, you can maybe scroll and see what the output looks like. And the second thing that I'm printing in this code block is just how many sender IDs did the code find. So roughly speaking, based on the pattern matching that I conducted, there seemed to be 3, 2, 5, 4 instances of a line which starts with from and contains something in angular brackets. Of course, there's also email validation. So you might want to create something that looks for the @ symbol. You might want to look for .coms and like the other domain name. So there's Spinfinder, Maktub, ePatra, a whole bunch of names. So if you want to just look for domain, running another adding to some complexity to your regex pattern will help you extract even more like detailed information. Right now, we've this is a simple code chunk for extracting the sender address. Yeah. Oh, great question. So in the way Python the re.match function works, it's basically its default behavior is to return a Boolean. So it'll tell me if the match is true or false, like did it find the match or not. If I want to actually get an instance of the match itself, I might have to tell it to return a group for me. And in this case, a group is what's enclosed in the round brackets right here. So I'm not interested in anything before an angular bracket. I'm not interested in anything after an angular bracket. Just tell me what's inside the angular brackets. That's my question. And just to illustrate this, I'll just scroll up a little bit. So we can look at this a little bit. So if we look at this email, for example, let me see. So if you look at the from line over here, you'll notice that the email ID is enclosed in angular brackets and there's a lot of text in its surrounding. So in order to make sure that I'm only getting the email and not the surrounding text, which is all part of the match, I use round brackets to create a group. So that's the match.group one. I can also use my code to create multiple groups. So I might want 3 groups. I might want the name of the person. That's anything that's after the colon and before the angular bracket. I might just want, so groups just help you chunk your pattern so that you can extract one or more parts of it separately. Okay, now just a little exercise here. If you had to extract the subject line of the code of each email, what would be the pattern that you could use? Now, for this exercise, you could just copy the code in the previous code base, if you like, and the thing that you might want to replace is the pattern. The thing in the pattern line, anything that's between the quotes is your pattern. So you can simply copy this code, paste it, and try it on your own. I will give you 2 minutes just to try it out. And an important question over here is, if you run the 2 print statements, do you get the same number of subject lines as you get for the sender addresses? Okay, so just okay, Randall, that's a great question. Now, what we can do over here is simply copy the dot plus question mark, and what I'm going to do is I'm going to put it into regex 101, and let's just see what we get. Right. So if you look at the explanation that I have on my shared screen, the dot is matching any character except for line terminators. So we're ignoring the end of a line. And the plus question mark is matching the previous tokens as many times as they are seen or as few times as possible. So it's just a way to indicate lazy search. I just, some of this code, there are, given the paucity of time, there's a lot to regex that I can't put in words, but I hope that at least I can share with you the tools that help you find the answers that you might need. All right. So I believe we've had a 2-minute attempt. If any of you have chanced upon the answer, do feel free to, if you're on Zoom, add your code solution to the text. And if you're here in person, maybe you can just tell me what kind of symbols you think would work. And yeah, like there is a certain amount of trial and error to this exercise, but that's part of the fun, I think. So I'm going to change this to subject, just so I don't save it in the wrong place. I like to keep my variables clean, but all right. So if there's anyone who'd like to maybe call out what the first part of this of my pattern should look like, what do we want the line to start with? Correct. We're looking for the word subject. So let me just add that. And I'm just using a little group here just to make it character insensitive. I've tried a bunch of ways. This seems to be the way that worked out for me. Okay, so look for a capital S or a small s, followed by UBJECT, followed by a colon, and right after the colon, which would we want to extract everything that follows the subject colon characters, or do we want to ignore certain things? So we have the subject. In the previous case, we were only interested in what was in angular brackets. We wanted our code to ignore everything else. But with the subject line, we would need everything, correct? So just as a novice, like just a basic solution, all I'm going to do is look for the subject line. I don't care what comes after the word subject, and return something to me. Okay, and let's just see if this works. Oh, let's see. Oh, let me create a group by adding round brackets. Okay, so it returned me a bunch of lines which have which start with the word subject. Ooh, I see a lot of just by looking at the subject, I'm getting so much content for what certain spam emails look like. You'll notice the number of times, I don't know, the word spam itself is in the subject. I don't even need to read the rest of the email because the subject line itself is tipping me to it, right? Request for assistance, right? And so even before we crunch all of our data with major overhead, simple pattern matching returns us some usable data, right? And the other thing that we might want to look at here is we got 3988 matches. And let me just quickly check. And in the previous instance, we got 3254 instances. So this might be, maybe we got too particular about searching, about performing a search while looking for the email ID in the from lines. Who knows? I'll leave it to all of you to maybe assess why I didn't get the same number in both of these instances. That would be consider it a little take home. All right. Now, next thing is if I want to just look at salutations, okay, I want to see how the email starts. Now, I'm sure all of you have had to write a lot of emails in your life. And what would be a word that you would use to greet your email recipient? You can call it out in the room, or you can even enter it in chat if you'd prefer. Hi, hello. Yeah. So we might, if I'm curious about salutations, like just a simple solution would be to look for the word, say, dear across my email. So I want to know how many times the word dear appears in a salutation, right? So something that I can maybe do is is just, I'm just looking for the words dear and attention. And if you've taken a look at the subject, you might find some more very interesting words that could be a good fit for this context. And I invite you to give that a shot. For the example here, I'm just going to use dear and attention. And it's the same for loop as before. What I'm looking for is a line that begins with the word dear. So maybe the word dear exists in the email content, but I'm looking for a line that starts with it, right? Just as a simple case to understand my data better. And I've used a pipe here, which is used as an or operator. So I'm looking for the word dear followed by a space, or I'm looking for the word attention followed by a space. I want to get an either dear or attention, but not in this case, not both, right? And you'll notice that in the little re.search option that I've used over here, it offers me an ignore case option. So I want to look for both capital DEAR, any kind of capitalization for these words. Right, so if you run, the only thing that I have asked the code to return is the number of times it saw the word dear or attention, right? So I'm going to insert a little code line here and simply get the list itself. Okay, so it's only returned what I asked it to return in the group by using my round brackets is just the word dear or the word attention. Now, if I want to actually return the entire line, because I want to see what comes after the word dear in the line, I'll let all of you make modifications to the pattern over here to extract the entire line of the salutation and not just the word. Okay, how do we do it? I believe we might want to add some wildcards following the word dear or attention, and that will give you the whole line. Okay. Now, we've looked at some basic parts of our email in an attempt to basically subset our data, look at parts of the data instead of the whole by using intelligent pattern matching. And another use case above and beyond what we've looked at so far is if you're interested in examining the actual email content itself. And I think earlier, if you had a few minutes to print out different lines in the data set, sorry, you would have noticed that sometimes you'll see HTML tags right in the middle. So you might just see, why is there HTML in the middle of a serious email about a dying Nigerian prince? So, instead of like language processing, pattern recognition itself could tell us so much about our text. So, if the email is in all caps, again, we have you can now extract all lines which have weird capitalization. So, you could look for, show me every word that starts with a capital letter, and a sentence which has, I don't know, 5 or more words which are capitalized. Or you could also look for random strings which are made up of alphanumeric symbols. So you've got a $sign followed by a star, followed by a dot, followed by some kind of weirdness. That could be a tip off that the email is might be weird. And finally, like all of you pointed out, we've got the random big numbers. So, if you're looking for a $sign followed by a whole bunch of like 7 or more digits, many of them might be just 10,000, 10 billion, 4 billion, whatever. Like, so you could scan your email just for those instances, right? And I've added just a little empty code space here for all of you to maybe take the next couple of minutes to just perform some pattern matching and tell me what you found. I mean, anything that your data exploration journey brought you in contact, right? And there's a little optional discussion. I asked ChatGPT what would be the most user-friendly and explainable way to extract the actual email body, right? So if we take a quick look at at some of the text that we have here, if I just want to, I just want the email and I don't want all of these headers, is there a way to basically exclude all of the lines uh, that precede the email content and simply get the text and leave out everything else? It's a little bit advanced for me, so I decided to see what the code might look like, and this is what ChatGPT thinks would be a good way to pattern match and extract the code, the email text itself. So I'll just quickly go over what this find a way to read this regular expression pattern, right? To simply explain the problem, we want to look for all the content that follows a line that has the status of the email. That's the last line in the email header, and we want to save all the text before our engine encounters a line that starts with from space R, right? So we're just going to preserve anything that's between a line that starts with status and the next line that starts with a from, exclude everything else, right? That's our problem. And the pattern itself, it says, yeah, let's look for the word status followed by space, followed by any number of spaces, followed by the number 0. Status 0 is something that we keep seeing. Then it wants to look for a new line or any one or more instances of a new line. So there could be 1 line after status or 10 lines. We don't care. Then we create a little group where it's basically collecting all the content that it sees after the status line. And it's going to do a little look ahead. It's going to basically stop when it finds a line that starts with from. Right? That's basically what it's doing. So that's what the question mark over here followed by another group is. So the second group that we created over here is the point where the regular expression search is going to pause, it's going to stop, and then it's going to try again. And this way we can extract every instance of an email in it. And I invite you to try this little chunk out, see what it tells you. And the most important thing here is we have a sense of how many sender IDs we have. We got we ran a regular expression to assess how many times we got the word, we got a subject line, as well as how many times we got a from line. So does the number of times that our regular expression returns the email body, does that number match with the other 2 numbers? If it does, then we probably have the right code to extract every instance of the email body. And if you're getting a smaller or a bigger number, something's up. And why would this be of interest? Just the kind of pattern matching that we're doing here, it tells us a little bit about the data. So when we feed all of this to a large language model to process and extract subject lines, we get a good sense of where our code might fall into, might have an issue, right? So it's just a little code chunk. All you have to do is try and run this code and see what comes out of it and see what you think of the code. The only other thing here is I just processed, instead of processing all of my email data set as a number of lines, I just looked at it as one massive string, just for ease of access. That's what the req.text is. Right. And so I leave you with this relatively more challenging regex task, just to assess like how far we've come in the world of NLP. Today, a lot of these problems are solved very easily, but like the building block or the starting point for us was pattern matching, and it really is a testament to how far the field has come from something that's very simple and algorithmic to something today that's basically working as a black box, right? For future further reading and resources, I love the regex cookbook. It's a great way to get started. Another great tool that I use is Learn Regex, where regular expression topics are divided into chapters. You get a little exercise at the end of every 10-minute chapter, and you can basically assess how far you're going with your regex journey. There's also regex1. Regex1 is the learning is one of the learning tools that I used. There's also regex crosswords. So if you're interested in in challenging yourself with cryptic crosswords, regex is something that's often used for them. I admit I'm not as advanced to solve them by myself, but it's a great team activity, group activity if you're into it. There's also lots of platforms. Like I said, I mean, you can incorporate regex into code with almost any platform that you use. I invite you to use it if you're writing on Overleaf, if you're using Google Docs. Add a little something to your searches, and always remember that there's a lot of help and there's a lot of support, and that there's no there's all kinds of interesting ways to apply regular expressions that I may not have had a chance to cover today, but yeah, do let me know how you'd use. All right, and with that, let me stop my share. And we have like a minute. If there's any questions, I'll save them and see if I can go ahead and look for them. And if not, thank you so much for joining us today.